Hello, Swami, can you hear me now?
Shivach, I just changed my headset. Am I audible now?
Yes, Swami, you are audible. Can you hear me? Hello. Hello, am I audible? Can somebody comment?
Yeah.
Thanks. So for a couple of more and let others join and then start the session. All right, let us then start this session. So in this session, we are going to primarily look at the practice assignments from weeks 5 and 6. And if you have any questions regarding these weeks in particular, and if you have any further questions, you can ask here and we'll try to answer those. We also have Swaminathan, another co-instructor for this course, joining this call. So he would also be chipping in if you have any questions regarding the content covered so far. So first, we will be discussing the practice assignments from week 5 and 6. Let me share my screen. So are you able to see the screen?
Yes.
Okay, all right. So this was the practice assignment from week 5, which primarily covered the application of linear regression to a constant elasticity model. And then subsequently, there was a discussion or an introduction to operations research and linear programming in particular. So the first question in this practice assignment was the following. You have been given the following linear program with a maximization objective subject to two less than or equal to constraints. And the two decision variables here, x1 and x2, are non-negative. As you can see from this formulation, it is more like maximization of revenue or profit subject to some resource constraint. That is how you can look at this formulation as of now. And in this formulation, you have the parameters A, B, C, D, E, and F greater than 0. Now, you have the concept of a dual variable introduced in a lecture in week 5. So what you now are given is that the dual variable corresponding to the first constraint is y1 and the dual variable corresponding to the second constraint is y2. After solving the primal, you find x1 star and x2 star. And x1 star and x2 star turns out to be equal to C, which is the first constraint. So the left-hand side in the first constraint is x1 plus x2. Now the optimal values of x1 and x2 are x1 star and x2 star. And you find that they sum. And with respect to the second constraint, you find that the left-hand side is less than the right-hand side. So the question is to find the value of y2 star. Before proceeding further, I would like someone to answer on what the concept of a dual variable is. What is the dual variable signifying here? Can anybody comment on this so that we can proceed further? You can maybe type in the chat box as well. Or it may be better if you raise your hand and answer. Does anybody want to take a shot?
To be honest, I have not gone through these lectures, so can't comment.
Okay. Has anybody else gone through the lectures from week 5? I think it would have been released a while back. So has anybody gone through this? No? Okay. So the dual variable signifies the shadow price of the resource. So the first constraint here could signify some resource which is available with you, and you are using that resource to produce x1 and x2. Similarly, there is another resource which corresponds to the second constraint, and you are producing certain goods x1 and x2 with those resources, right? So this dual variable signifies the value or the shadow price of this resource. Now you have solved the primal, found the value of x1 star and x2 star, which are the solution. And you find that the first constraint is satisfied as an equality and the second constraint is satisfied as a less than or equal to type. Now, since the first resource is completely utilized, you cannot get it for free, right? You value that resource so much. But when you come to the second constraint, you have not utilized the resource completely. No way in which you are going to go to a market and buy that resource because you have that resource yourself. Therefore, this value of y2 star or the shadow price of the second resource is 0 in this particular case. Okay. Does anybody have a question here? It would help if you look at the video content from week 5, but if you have any question, you can ask them now.
So y1 is a combination of x1 and x2?
No, y1 is the value of resource 1. So the first constraint here is x1 plus x2 less than or equal to C. This is the first resource constraint. Now, how much do you value this resource is denoted by this y1. And similarly, for the second constraint, y2 denotes the value of the second resource. That is what it signifies. Maybe I would suggest you to look at the lecture so that
Sure.
been elaborately covered there. If you have any questions, you can come back here. Okay, so if you don't have any questions here, we can move to the subsequent question. The second question is on implement a simple linear regression model on a constant elasticity model, where the demand is equal to C, which is constant, into price power minus epsilon. And you perform this linear regression after performing a log-log transformation. And the results indicate that the intercept is equal to 100 and the slope is equal to 50. Now, if this is the case, the question is to find the value of C and the value of epsilon. So the way you would approach this problem is to first convert this D equal to C into P power minus epsilon into a linear regression after performing a log-log transformation, right? So let's write through that. So what you have is D is equal to C P power minus epsilon. Since you are performing a log-log transformation, you can take the logarithm on both sides, which is ln of D equal to ln of C into P power minus epsilon. Okay. And if you decompose this further, you still have ln D equal to ln M into N is equal to ln M plus ln N.
Yeah.
So we have ln C, the natural logarithm of C, plus the natural logarithm of C P power minus epsilon. Okay.
You need to remove C
Yes.
from the second part. C is not.
Yeah. Sorry. So you wouldn't have this. So it is ln P power minus epsilon. You're right. So now we have ln D, and ln D is equal to ln C plus minus epsilon. So let me write it clearly. Minus epsilon into ln P. This is because you can write ln M power N as N ln M, right? If you could recall your basic math, you would understand this.
Yes.
So this is what you have at hand. So we have a clear case of a simple linear regression. What do we have on the left-hand side is ln D. Then we have ln C plus minus epsilon into ln of P. Now let us go back to the question. We would understand that the intercept value is equal to 100, right? So the intercept value for this question was equal to 100 and the slope was equal to 50. If in case you come back here, so we come back here, so the intercept is equal to 100. Therefore, 100 is equal to ln C.
On C. Yeah.
Now we need to find the value of C. How do you do that? Is to take an exponential on both sides. So e power ln something is something. Okay, so e power ln of C is going to be C, and therefore e power 100 is going to be equal to e power ln C, which is going to be equal to C. Therefore, C is equal to e power 100. Now, looking at the slope is straightforward, because you have the slope values equal to 50 and you have epsilon equal to minus 50. Okay. So this is how you solve the second and the third problem. Have any questions up until here?
Just related to sign of the epsilon, normally like it is mentioned in the lectures, we should remove the negative sign. So which option we should select, A or B?
sorry, where it has been mentioned that we have to remove the negative sign. So a simple linear regression model generally has a plus bx, right? So that is the structure of a simple linear regression. So when you look at the epsilon value, you have minus epsilon equal to 50. Therefore, your epsilon value is minus 50. That's it.
Yeah, this is elasticity, right?
Yeah.
So elasticity in the price demand curve, it
Mhm.
is negative, but at the end it says like we should apply the minus sign to make it positive value.
Not applying minus sign to make it positive. So in general, you have the negative sign because the change in demand. So if you're going to change the price from P1 to P2, where P2 is going to be greater than P1, the demand will naturally come down.
Yeah. Yeah.
So therefore, in order to capture that, we are only looking at the particular case where the negative sign will capture that change.
Yes,
So
exactly. Yeah.
so it's nothing more than that. Now, when you say epsilon, or if you ask the value of epsilon, you need to report it as minus 50.
Okay, fine.
Yeah. In this particular case. So the next question is on the following. So you have the following demand function where the demand is equal to 100 minus 4p. The demand is dependent on price. Now you intend to maximize the revenue, and the revenue is going to be demand into price. And you find the first derivative of Rp with respect to P, equate it to 0 and find P star. Now, what is the value of P is the question. P or P star is the question. So can again solve this. This is again not very difficult. I'll go to one slide. You have the revenue function to be equal to 100 minus 4p into p. You intend to maximize this. So before doing that, let me simplify. It is 100p minus 4p square. Now, if we perform the first derivative of Rp with respect to P is going to be 100 minus
8p.
P. So equate this to 0. Right? Equate this to 0. And you can find that the value of P star is 100 by 8, which is 12.5. Okay. So this is how you calculate P star. But you are not guaranteed that this is going to be the maximum, the price which is going to generate you the maximum revenue. In order to do that, you need to do the second order check. So if we do a second order check here, that is what we are doing is we are doing d square of Rp respect to P square. So take the second derivative with respect to P. You find that this is going to be equal to minus 8 because 100 is a constant. It will become 0. Minus 8 into P. P is the variable which you are differentiating with respect to. So it is 1, and you have the second derivative to be minus 8. So if the second derivative is going to be negative, you can conclude that the revenue function is concave, and subsequently you can conclude that the revenue function is so the price at which you are maximizing the revenue is obtained. Okay, so only with the second derivative you can confirm the following.
So if it comes out to be positive, then
it is not going to be a concave function. If it is positive, it is going to be a convex function. Then you are not guaranteed that that price is the one which maximizes the revenue.
Okay.
So this is all we have from week 5. Okay. Then if we are fine with this, we can quickly jump to week 6. So do we have any questions until this point? If not, let's proceed with this next week's practice assignment. Week 6 was primarily focused on multiple linear regression, and you have been given the following, and most of these questions I think follow from the first paragraph here. So you are conducting a multiple linear regression with sales as the dependent variable, and price, quantity, and rating score are the independent variables. Now the first question is to find the variance inflation factor for the variable quantity. So in order to find the variance inflation factor for a particular independent variable, what you do is you construct a regression with that variable of interest as the dependent variable. In this case, that variable is quantity, and the other variables as independent variables. Okay, so you construct a linear regression where quantity is going to be the dependent variable and the other variables are variables. And it turns out that you obtain an R squared of 0.43. Now, what is the variance inflation factor for this variable quantity is the question. Now, if you look at this question, you have the formula ready at hand. It is 1 divided by 1 minus R square, which is 1 divided by 1 minus 0.43, and you would get about 1.754. Okay, so that's the variance inflation factor for the variable quantity. So that's what you get. Okay. So the next question is finding the total effect of price on sales. So there are different independent variables in a multiple linear regression affecting the dependent variable. You know that the price directly impacts the sales in a certain way. So you can get that from the coefficient directly, but you would also want to know the indirect effect of price on sales. Therefore, you are given the following data. You find that the direct effect of price on sales is 0.34. The direct effect of quantity on sales is 0.22. The direct effect of rating score on sales is 0.48. And you also know that the effect of price on quantity is 0.22. Okay, and also the effect of price on rating score is 0.1. So now the direct effect of price on sales is directly captured by this 0.34, and the indirect effect of price on sales has to be captured by the growth. So price affects quantity, then quantity affects sales. Similarly, price affects rating score, and rating score then affects sales. So if you can capture these indirect effects and sum it up with the direct effect, you can obtain the total effect of price on sales. Okay, that is what we do here. So we have the direct effect on price on sales to be 0.34, the indirect effect being 0.22, which is the, so the first 0.22 is the effect of quantity on sales. Now the price also impacts quantity, which is another 0.22. So you multiply 0.22 by 0.22. Then subsequently, rating score affects sales with respect to 0.48. You multiply this 0.48 with 0.1, sum all of these across, and you have these three factors, you sum it across, and you obtain 0.4364. So this is the total effect of price on sales. Okay, so there is a variable price directly impacting sales to a certain extent, and also indirectly affecting sales to a certain extent. And that is what we calculate in this following problem. Okay, and the final question is a question which is very relevant to multiple linear regression, and that is on the adjusted R squared. So adjusted R squared is an important concept with respect to multiple linear regression, because if you just consider the R squared value in a multiple linear regression, what will happen is if you simply keep on adding independent variables, say you are adding hundreds of independent variables, every time the R squared value will start growing up. So you wouldn't know whether the model is actually good or not. By simply adding independent variables, you can report higher R squared value, and that is going to be incorrect. So therefore, this notion of adjusted R squared is introduced to correct for this factor. Even if you introduce newer variables, that shouldn't simply add up your R squared, right? So therefore, this adjusted R squared is a cleaner metric which will help you understand how healthy your multiple linear regression model is. Okay, so this is the interpretation which you should know at this point. You need not go in detail, but if you can understand and appreciate why adjusted R squared is a metric which is required first and why better than R squared, that would be sufficient. Now let's come back to this question. So the question is the following. You have a multiple linear regression with 3 explanatory variables, and you find that the R squared value is 0.74, and the number of observations for this multiple linear regression has been 25, and you need to find the value of adjusted R squared. So the adjusted R squared has a formula. You would see that, I think, in a certain lecture. So when you apply this formula with the following values directly, you can get the solution. I think it is 1 minus 1 minus R squared into n minus 1 divided by, sorry, yeah, this is what we have. So it is 1 minus R squared, which is 1 minus 0.74 into the number of observations minus 1, which is 25 minus 1, 24, divided by n minus k minus 1. N is the number of observation, k is the number of explanatory variables, which is 3 in this case, minus 1 is the one which is removed. So when you do this calculation, you obtain an adjusted R squared of 0.703. You can clearly see that the adjusted R squared value is slightly lesser than the R squared value. That's the penalty which you are giving by simply adding on multiple variables. If you don't have an adjusted R squared value, if you simply keep on adding a lot of independent variables, which might potentially impact or not impact the dependent variable, you can simply start reporting higher values of R squared, which is actually not true. And therefore, R adjusted R squared is a cleaner metric. Right? So that's all we have from week 5 and 6. Do you have any specific questions from week 5 and 6 which we can talk about?
So when reporting such data R square values to the management, we should use adjusted R square because that gives true picture.
Yeah, especially when you're doing, particularly when you're doing multiple linear regression. That's when adjusted R squared value comes in.
Got it.
And it's also a good practice to report other metrics such as the root mean squared error, which we have discussed. So those are different. There are different metrics to assess the model's capability. So you can report the other values as well to suggest how the model fits the data. Is it overfitting or underfitting? All that.
All right.
Okay.
Good evening, sir. I
Yeah,
have
good evening.
question from the week 6. Sir, I could not understand the collinearity. Reverse means, suppose in the example, sir mentioned that suppose written test marks and the interview marks and both influence the CGPA. But sir, written test marks affect the interview marks indirectly. That is we can understand. And but sir, how interview marks can affect the written test marks indirectly, because that event has already happened. Means there are two events.
Okay.
Written test has happened earlier, and present event can affect the future event, but present event cannot affect the past event, na? In
Okay,
real
so
life.
the way to look at that is you have an interview mark. So are you suggesting that interview marks is a particular one independent variable 1 and the written marks is independent variable 2, and you want to suggest how they are impacting each other, the collinearity problem there?
Yes, sir. Indirect wala.
Yeah. So the way to look at it is, so there might be variables which may not be that correlated, or they may be correlated. So if it is correlated, we want to capture that. So that's the reason we would want to look at adjusted R squared or other metrics. So now the written marks could possibly affect the interview marks or not affect the interview marks. So if you consider them to be independent events, you should consider the first case as well, right?
Mm-hmm.
So the concept here is you have two independent variables. These independent variables may or not move with each other. You don't know that. So to have such variables in your independent variable set, you need to find the direct effect and the indirect effect. It might well be the case that the indirect effect of a certain variable on a certain variable might be 0. That could also be very well possible, right?
Sir, I understand that part. Means lectures, I understand well. It's means ki, all the variables means affect each other indirectly.
We are not commenting that all variables will impact each other. They may or may not impact each other. So you have certain metrics to suggest that they impact each other to a certain extent or not to a certain extent. So that thing can be captured. So in a multiple linear regression, what will happen is you would keep on adding a lot of variables sometimes. Let's say today you believe that price is affecting sales. And tomorrow in your regression model, you would want to add a particular variable. Let's say you come up with a promotion for your product. You want to capture the effect of that promotion on sales. Then you come up with a new ad which is being introduced on TV, then you would want to understand that effect on sales. So if you are going to add a lot of these variables, you don't know whether these variables impact has been already captured. It could very well be captured by another promotion variable or a price variable. So this movement or the interaction between all these variables is captured. You need to make sure that they are not strongly correlated. And that's the only thing you should be aware of at this point. And if you want to be aware of this, look at, say, the adjusted R squared. Adjusted R squared will say you, if you're simply going to add a lot of this, I'm not going to give you a higher R squared because I'm giving you a penalty for simply adding up variables. So that's a slightly closer to reality metric. So that's how you need to look at it.
Shivatsa, am I audible now?
Yes, Mami.
Just wanted to give another example for this multicollinearity thing.
Yeah,
so let's say that we want to predict how much Rishabh Pant is going to score in the next match. So we'll have a lot of features like how many 50s he has scored in the past, how many sixes, how many fours, what is his average, and so on. So if you look at all these independent variables, there is going to be correlation. Then the number of runs will be directly proportional to number of sixes, number of fours, and so on. So there will be a lot of multicollinearity within the independent variables. So therefore, in order to account for all these things, we use the metric called adjusted R square. I just wanted to give another example for understanding multicollinearity. That's all. Over to you, Srivatsa.
No, sir, my question is, I'm not able to still get my point. Suppose, miss, there are two events. Suppose I want to go from, suppose if I am in the Punjab and I want to go to the Chennai, then I have two routes. Miss, I have to go first Delhi, then I have to go from Delhi to Chennai. So for first event, I can understand that suppose if I get traffic, then my future event can be affected. But how future effect can impact the past event? So am I able to communicate my doubt?
So you're saying the interview marks is some future event, but was the interview marks the dependent variable or an independent variable?
So interview marks are the independent variable.
Okay.
And written test marks
is an independent variable. What is the dependent variable here?
Dependent is the CGPA marks,
which they are going to score in the particular course.
Yes.
So you need to look at it, I mean, in the plain vanilla fashion in the following. You have interview marks. So you have the record of interview marks of the particular student. You have the written marks of the particular student. Now you have this data and you are trying to understand that data's effect on CGPA. Do you have any relationship or the impact of this data on the CGPA? So that's the problem which you are looking at. No more complexity added. So that's it. So if you are going to look at what how this independent variables will have direct effect and indirect effects, that could be very, I mean, it could be in multiple ways, right? So if candidate is going to be good communicating well, or there might be some candidates who will be communicating very well in the interview, but the written test, their written communication may not be that good, or they may not be very good in this OMR type test. So you don't know. We are not getting into all those complexities. We are just suggesting you there are two independent variables that is impacting the CGPA in the course. So that's the problem which you are looking at. And we are suggesting that there is a possibility that these independent variables might be correlated. That's it.
Okay,
no more
sir.
complexity.
Okay, thank you, sir.
Thank you. Yes, Puneet.
Hello, sir. Am I audible?
Yes.
I was trying to understand Yogendra's question. Yogendra, are you there?
Yes, I am here.
Right. So we're talking about collinearity, right? That's the lecture. They are saying that both of those are collinear for final GPA. Hai ki nahi?
Yes.
Okay. So if I ask you, how much rent do you pay, or how much money you earn as a metric for your success, either of them can be collinear to detect that if you're paying a 1.5 lakh rupees rent per month, I know that you are very rich, or your income is over 50 lakhs per year, then you are rich, right? So now in an oral test or a written test, the marks of both, won't they indicate what my final GPA might be? There will be outliers.
Okay. So
won't a written test and an oral test both indicate what the final GPA could be?
Okay. So the thing is, you have these independent variables. The data will tell you whether they are collinear or not collinear.
I'm not asking a question. I'm agreeing to what you said. I am trying to ask if it makes sense or not. That they both are exams, they both are estimates of how much knowledge I have, my written test or my interview. So both will affect, right?
Yeah, both will affect. And thanks for adding this. So the thing is, we should all comment based on the data we have. These are all hypotheses which we have currently. These two might impact together, they might impact alone, or they might impact, they both may not impact at all. So in that case, we would have a very low R squared. So all these are consequences of what you do. When you look at the data, do the analysis, construct a linear regression, only then we can comment on what we actually see. These are all the hypotheses which we currently have. That
Agreed.
makes sense?
Agreed, yes.
Yeah. That's why you have, you need to check whether the regression is significant or not significant. And that's the reason we do that check. So do you have any other questions now? If not, Swami, do you want to add anything specific with respect to any week?
Yes. So perhaps this week could be a shorter session. I'm not able to log in via my computer. So next week we'll have a little longer session where Malolan and I will cover logistic regression. And also there were a few doubts on the normal distribution coding part. So when you want to fit data and you want to fit the normal distribution for that. So there is some confusion, especially in splitting the bins, right? So that was not clear from what tutorial we did. So we'll do another tutorial there. We'll give you how to, we'll make you understand how do we split those bins and things like that. In the next session, we'll have a detailed discussion about the normal distribution fitting and so on. So, and apart from that, quiz questions, there were a few typos, especially with respect to the answer on satiating price. And there was a graph where the axis was not linear. So all those typos will rectify, and we'll reevaluate your quiz one. And then we'll send an update for the updated scores. That's all, Srivatsa. Any more questions?
We don't have any other questions. I think can close this session then. Thanks, Swami, for joining. Thank you all for joining in. Wish you the best.
Thank you.
Srivatsa.
For a nice session.
Thank you.
Thank you. Thanks, guys.